Hi, welcome back to Science 1206, the motion unit. I'm Ms. Ledwell, and in this video, we'll discuss how to calculate displacement from velocity time graphs. Let's get started. The area under the line on a velocity time graph can be used to calculate the displacement of the object. In cases of uniform motion, where velocity remains constant, this area takes the shape of a rectangle. The formula for the area of a rectangle is length, representing the time interval, times width, representing the velocity. Note that the boundaries for the area are the line on your graph, the x-axis, time, a vertical line you draw from the end of the line on your graph to the x-axis, or time, and sometimes the y-axis, velocity. So calculating the area under the line will give us the displacement. Remember that area of a rectangle is equal to length times width. So the length of this rectangle is 4 meters per second north, and the width of this rectangle is 4 seconds. Seconds cancel out, and then we're left with an area of 16 meters north. That is the displacement. The displacement after 4 seconds was 16 meters north. When dealing with non-uniform motion on a velocity time graph, the line is sloped. To calculate the displacement, look for the area of the shapes formed under the line. For a triangle, the area, and therefore the displacement, is calculated using the formula area of a triangle is half the base times the height. The base represents the time interval, while the height corresponds to the change in velocity within that interval. Let's calculate the displacement by finding the area under the line in this graph. The shape that the area under the line forms on this graph is a triangle, and the formula for area of a triangle is half the base times the height. The base is 4 seconds, so we have half times 4 seconds times the height of this triangle is 8 meters per second east. The area then is 16 meters east. The displacement after 4 seconds was 16 meters east. Now it's time to do some practice problems. Pause this instructional video and grab a pencil and some paper, or open up a blank document on your electronic device. As the next slides are revealed, try the problems on your own. We will then review the answer together. After collecting your writing supplies, please resume this instructional video. Our first question is, what is the velocity and displacement of the object whose motion is depicted in the graph below? So first we're going to find the velocity. To find the velocity, we're going to read it off the graph, off the y-axis, and if we go straight across from our line, we can see that the velocity is 8 meters per second north. Next, we're going to find the displacement. Remember that to find the displacement on a velocity time graph, you need to find the area under the line. So I'm going to extend a line down from the end of the line on the graph, and the shape that forms is a rectangle. So I'm going to need to find the area of the rectangle. So area of a rectangle, the formula is length times width. The length of our rectangle is 4 seconds. Times the width of our rectangle is 8 meters per second north. Seconds cancel out, and that gives us an area of 32 meters north. The displacement after 4 seconds was 32 meters north. Our second question shows a graph depicting the motion of a bug. First, we're asked to find the velocity of the bug in section A. If we draw a straight line across from the line on our graph to meet the y-axis, we can read off the velocity, and the velocity of the bug in section A is 2 meters per second forward. Our next question asks us the velocity of the bug in section C. So we're going to do the same thing again. Draw a line from our graph over to meet the y-axis, and then we can read the velocity off here. And the velocity in section C is 4 meters per second backward, or you could have said -4 meters per second. Next, we're asked to find the velocity of the bug in section E. We're going to do the same thing and draw a line across from our graph to meet the y-axis, and we can see that the bug is not moving here. The velocity is 0. Our third question asks us, in section A of the graph, is the bug moving forward, backward, or is it stopped? The bug is moving forward in section A because the velocity is positive. In section C, is the bug moving forward, backward, or is it stopped? In section C, the bug is moving backward because the velocity is negative. And last, it asks us in section E, is the bug moving forward, backward, or is it stopped? And in section E, the bug is stopped because the velocity is 0. Question 4 asks, for the graph shown below, what is the displacement in the first 5 seconds? So the first thing we're going to do is draw a line to connect 5 seconds to the line of our graph. To calculate the displacement, we find the area under the line. The shape formed is a rectangle, so area of a rectangle is length times width. So the area equals the length, 5 seconds, times the width, 2 meters per second forward. Seconds cancel out, and that gives us 10 meters forward. The displacement after 5 seconds was 10 meters forward. Our next question asks, for the graph shown below, what is the displacement for the first 3 seconds of the trip? So remember, to find displacement from a velocity time graph, you need to find the area under the graph. Your first step is going to be to draw a line down to form our shape. So we're drawing a line down to the x-axis, and we can see that our shape is a rectangle. So now, to calculate the displacement, we need to find the area of a rectangle. Formula is length times width. So we have 3 seconds is our length, times 10 meters per second east is our width. That gives us 30 meters east. Our seconds cancel out. The displacement for the first 3 seconds was 30 meters east. Our next question is, for the graph below, what is the displacement for the 6 seconds of the trip shown in the graph? So our first step is going to be to draw a line up from our x-axis to meet the line on our graph. And we notice that the shape that's formed is a triangle. To find the displacement, we need to find the area of a triangle, which is half the base times the height. Our area is half our base, half times 6 seconds, times 10.0 meters per second east. This gives us 30 meters east. The displacement for the first 6 seconds was 30 meters east. Now it's time to continue to the next video. Give yourself a 30-second wellness break. Stand, stretch, and get ready for the next video.